Alright, I'm going to do the troglodyte war question from the homework. Question part 1. This one right here. It says a colony of troglodytes have been in a lengthy feud with their neighbors, and colony 1 starts rolling bombs off their side of the cliff. They know how fast they're rolling them off, and they're able to choose that speed to hit the other side of the cliff where they want to. We know the distance between the cliffs, and it tells us that if the left side colony rolls it off the cliff at a certain speed, they want to know how far down it's going to hit. So we're to calculate this distance here, the delta H. I'm going to get my grid and start filling in the values. I know that the distance between the cliffs is 42.1, so if it starts at the left side and when it gets to the right side, it's going to have traveled 42.1 meters. The bomb rolls off at 5.6 meters per second. That's in the x direction. So it starts at 5.6 and it ends at 5.6 in the x direction. How far down the opposite side will it land? That's in the y direction. So if it starts at the top of the cliff, I want to find out where it ends at the bottom. And it tells me acceleration is 9.8. So I'll say negative 9.8 for downwards. I'll start the timer at 0. I don't know how long it's going to take. The speed, when it first starts out in the y direction, I know it's going to be 0, or it is 0, because when it starts out, it's not moving up or down at all. It just goes sideways, so the speed down is 0. I don't know my time over here either, so I'm going to put a question mark on that. Now, we want to calculate how far down it goes, but the one thing I know is that the sideways distance is 42.1, and it's traveling at a certain speed sideways. So I can use the right-hand side to calculate how much time it's in the air. So using the second equation, delta x is equal to vix delta t. I'm going to solve for delta t, and I get the change in position in the x direction divided by the velocity in the x direction. So that'd be 42.1 meters divided by 5.6 meters per second. Grabbing my calculator. 42.1. Let's see if you can see that. 42.1 divided by 5.6. So it's about 7.5 seconds. We'll put down a few digits. So I can fill in my time up here, the 7.517 blah 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 seconds. And I also know my time over here now. And now I can go after what I'm really looking for is how far down the cliff the final position, or the delta y. I've got to find something that doesn't have the final velocity in the y direction and still lets me calculate the delta y. So I'm going to choose this one here, I think. Delta y is equal to vi delta t plus 1/2 gravity delta t squared. This term goes away because my initial velocity in the y direction is 0. So I can just calculate using the second half, 1/2 of a negative 9.8 times the amount of time of 7.51786 seconds squared. So 0.5 times negative 9.8 times 7, well, second answer, negative 36.8375. And they want the absolute value. So we're going to take this. Oh, I didn't square my answer. Wrong. Negative 276. And multiply by half. Alright. So that's wrong. Negative 276.939 meters. There we go. Alright, so that's it for that part of the problem.